All right, guys, we are on to lesson 1.3, and today we're going to learn about something called exponents. So an exponent is just a faster way of multiplying something and not having to write out the stretched idea of what we're multiplying. So for example, instead of saying 6 times 10 times 10 times 10 times 10, we could say something a little bit different. We can still keep our 6, and then we say to ourselves, how many 10s do we have? We have 1, 2, 3, 4 10s. So this here is the exponent, 6 times 10 to the 4th. The reason it's 10 to the 4th is because I have 4 10s. So instead of going 6 times 10 is 60, times 10 more is 600, times 10 more is 6,000, times 10 more is 60,000, I can say, oh, 6 times 10 to the 4th. Well, that's 10 4 zeros. 10 4 zeros. Not 10 plus 4 zeros, but 10, which has 10 and 4 zeros. So it's 4 zeros. So 6 times 10, we know is 60,000. That's all exponents are. Remembering that we're working that whole base 10 idea. So what we're going to do is we're going to do some practice. So if you don't have your notebook or scrap paper or something to work in, I want you to go ahead and go grab some. Pause while you do that. So if you see a number such as 100 and you want to put it exponentially, you have to break it down into base 10, which we're going to have our 10. But how many zeros do we have? We have 2. If I just put a 1 here, that's 10 to the first power, which means there's only 1 10, and I've got 10. So I wouldn't put a 1 there. I have 2 zeros. Even though 10 already has a 0, you count your total number of zeros to put as your exponent. All that means is 10 times 10. And we know that equals 100. All right, let's do another. How about we do 1,000? Go ahead and write that down and tell me what that's to the power of. Well, hopefully you said, well, 10, because I know it's base 10, and it has 3 zeros, so it's 10 to the 3rd power, because 10 times 10 times 10 equals 1,000. 100 times 10 is 1,000. If you think of that place value chart, and you're in the hundreds place, and you have 100, and you multiply it by 10, you're now in the thousands place. That's all we're doing. All right, let's do one more. I'll give you a harder one here. Go ahead and write this down. And then pause to tell me, or to write down, what the exponent would be that goes up here. Go ahead and pause while you figure that out. Hopefully you said that it was 6, because there are 6 zeros. 10 to the 6th power is the same as 1 million. That would be writing 10 times 10 times 10 6 times, and then solving it. All right, let's get a little more complicated. Let's go ahead and toss this at you. What if I had 100 times 10? Well, you know that's 1,000. But what would it be as far as the exponent goes? Well, let's look. I have this base 10, and I have that base 10. Since this is really 10 times 10, I really have how many 10s? 1, 2, 3. So my exponent should be a 3. We know 100 times 10 is 1,000. We know 10 times 10 times 10 is also 1,000. They are the same. All right, erase. Let's try another one. Let's try 1,000 times 100. All right. Go ahead and see if you can figure out what that 10 to to the exponent would be? What goes in that little box? Go ahead and pause while you think about it. Hopefully you said, well, this is ideally 10 times 10, which is 2 zeros. And this is ideally 10 times 10 times 10, which is 3 zeros. So I have 110, 210, 310, 410, 510. So this should be a 5. 10 to the 5th power. It's 1,000 times 100 is the same as saying 10 times 10 times 10 times 10 times 10. But instead of having to write all that out, I could just put it into an exponent. All right, let's look at another method. Let's imagine we are working with some decimals. Well, let's start simple. Let's say we have 43 times 10 to the second. What that means really is 43 times 10 times 10. I have 2 tens. Well, 43 times 10, remembering that place value chart we talked about yesterday, hundreds, tens, ones. If I do it times 10, they shift once. I do it times 10 again, they shift again. So my answer would become 4,300. If this is not making sense, you need to raise your hand now. All right, let's go ahead and do a practice one. Let's imagine we have 47 times 10 to the third. Go ahead and pause and tell me what the answer would be. All right, hopefully you figured out that this is 10 times 10 times 10, and you're just doing 47 times it. How many of you came up with 47,000? Because it's 47 and my 3 tens. 47,000. The last two things I want to teach you is that you can also do this with decimals. Imagine you have 32 and 45 hundredths times 10 to the second. And if that's the case, then you know you're doing times 10 times 10, thinking of that place value chart. If I shift everything over 2 times, I'm going to end up with 3,245. All right, go ahead and try this one on your own. 64 and 29 hundredths times 10 to the third. See if you can figure that out. Pause. All right, so we've got to the third power. It means I'm shifting to the left 3 times. So my new answer is 64,290. All right, the last thing I want to teach you is just about patterning. So be thinking about a pattern and which direction it goes or how it goes. So let's say I'm put here with a 4/10. And then up here, whoops, I've got 40. See if you can figure out this pattern. Well, it looks like I'm just moving my decimal at some point because my 4 is the same, it's in a different place. So this went from tenths to tens, so this would have to be 4 ones. And on the other side, obviously it moved, it's getting bigger, so this is going to be smaller. So think about what this would be. Hopefully you got 0.04. And then of course the last one, again, we're still getting smaller, and we know that the further you go past the decimal, the smaller it is. So this is 0.0044 thousandths. All right, go ahead and find a partner to do the problem set with. Remember, it's on Schoology under classwork. Good luck.